Good afternoon or morning, wherever you may be. Welcome to Cassandra.Lunch number 56. I will be the speaker today, and I will be covering using Spark SQL Parquet Tables in DSEFS and DSE Analytics. I am a junior engineer here at Anant, and this is my first presentation, not my first intro, but my first presentation, so bear with me. Our organizers for this event are Rahul Singh, Arpin Patel, and myself. And we are always looking for speakers and sponsors. So definitely spread the word. If you know anyone that would be interested or companies that would be interested in sponsoring an event like this, don't hesitate to reach out to any one of us. Our information is listed there at the bottom. We are part of a larger community, Data Community DC, and we do believe in a diverse culture. So we support all races, gender, sexual orientation, and expect kindness towards all that and acceptance. Some of the other organizations involved in Data Community DC are listed on the screen here. What we cover here, we cover everything related to Cassandra, DataStax, which is an enterprise version of Cassandra, and Spark, Kafka, anything related to big data, really, especially as it pertains to the Cassandra database. 15-second announcement, or actually, no, if anyone's new, they can introduce themselves, which looks like everyone has been here before. Group roles, if you have a question, ask it, be polite and courteous to others, and share what you know. This is meant to be a discussion. Being the speaker today, I don't mind if you unmute yourself or ask a question in the chat. Unmuting yourself actually might be easier than bringing up the chat. So I don't mind if you guys just unmute yourself to ask a question or contribute to the discussion. Here or not, we deal with big data at real time. Cassandra, Spark, and Kafka are our main technologies, and certainly not limited to just those. DataStax is also a partner with us, as well as GW University have been kind enough to let us host this event when in person at their facilities. So hopefully we'll be able to get back to in-person events again soon. Shout out to some of our program sponsors. You can see here, as mentioned before, DataStax, Eastern Foundry. And some of the organizational sponsors to Data Community DC are listed here as well. And 15-second announcements. If anyone has an event, meetup, job announcement, looking for a job, anything like that. Again, it looks like, okay. Anant is hiring full and part-time positions for data platform operator, engineer, or architect. You can find out more at careers.anant.us. And some upcoming Cassandra events. We'll have a guest speaker on the 7th of July, Anil Akula, using secondary indexes in Cassandra. Rahul Singh, our very own CEO, will be presenting a topic on the 14th, and then we'll have a topic on the 21st going over functions in Cassandra. We have a sister lunch to this every Monday at noon Eastern time called Data Engineers Lunch, so definitely feel free to join us there. As well as this is hosted every Wednesday at 12 p.m. Eastern Standard Time. So all our events will be listed at anant.us/events. So anything upcoming, you can definitely go there. As well as all the recordings for previous Cassandra lunches can be found at this playlist, Cassandra Lunch. If you search that in YouTube, or if you're watching on YouTube right now, it should be an option for you to go through and see all the topics we've discussed, and whatever you're trying to learn about Cassandra, I'm sure it's been touched on in one way or another. And Cassandra.Link is your best resource for Cassandra-related technologies or information. Don't hesitate to go there with any questions. You can see just in the tags there, we talk about a bunch of different things related to Cassandra. And this is a hand-curated by Rahul Singh webpage, and any sort of resources you're looking for regarding Cassandra can be found here. So without further ado, we'll jump into presentation for the day. So as I mentioned before, I'll be discussing Parquet Tables and DSEFS and DSE Analytics. So briefly, I'll touch on what is DSE Analytics, what is DSEFS, what are Parquet Tables. I'll discuss how DSE Analytics and the DSE file system works with Parquet Tables. And I didn't get the full demo running, but I'll be able to walk through and show you kind of what's happening in the idea of how some of the commands involved in using these Parquet Tables in DSE Analytics. Mainly Spark. So what is DSE Analytics? You can see here it's allows for real-time batch operations and analytics capabilities using an enhanced version of Apache Spark. And spoiler alert, Spark is actually what seems to allow the use of Parquet Tables. And you'll see that in the demo, the commands typically are run using the Spark connector. DSE Analytics can generate ad hoc reports, target customers with personalization, and process real streams of events. Some key features: highly available end user analytics through Spark SQL. Workload isolation, which is one of the key features I've seen about it, and faster operational analytics. The file system, DSEFS, is similar to the Hadoop distributed file system with their self-professed less complexity when compared to HDFS. A big thing with this is it avoids single points of failure, common with HDFS. And it is designed to work with Spark, as you guys will see. There is a separate storage of file metadata and file contents stored in the database, and it gets stored locally and replicated to nodes. So Parquet Tables, the main question of this presentation, and how they differ from CSV or JSON. The biggest thing is it's a columnar file format, which I don't believe I added my image here, but it reduces the main features of Parquet Tables is reduced storage space, I should say, by up to 75%, reduced IO operations. It fetches specific columns that you need to access. As kind of mentioned, it consumes less space. Oops, going in the wrong direction here. Supports type-specific encoding and in Parquet, metadata, including schema structure, is embedded within each file, making it a self-describing file format. So as I mentioned before, DSE Analytics and DSEFS, the Parquet features are largely supported through the Spark SQL. In my demo, you'll see some of the commands run and how Spark is used in that. This is a holdover from previous presentation. So let's go check out the demo. Any questions up to this point at all, or anything to add to what I've said so far? Take that as a no.
Yeah, just a question. So this is part of Spark. And so obviously technically it could be done anywhere. The question I have is, what is the, maybe you're going to cover it later, but like, what is DSEFS actually doing for us that like a regular disk can't do?
I'm honestly not entirely sure about that. I was reading more into Parquet file formats more than the DSEFS. Maybe you could add to.
Well, it's DSEFS is a distributed file system, so it's an unlimited hard drive, right? So at some point, your regular hard drive is going to not fit all the data, but you can have a Parquet table that is technically terabytes or petabytes in size. Whereas when you do that, DSEFS will figure out where to put all the files and distribute them across different machines. Mm-hmm. So not just DSEFS, the same thing as HDFS or S3, which implements HDFS, or Azure Data Lake. All of them use the same protocol for distributed file system access.
Mm-hmm. And so one thing I know that, as I mentioned, that DSEFS avoids that single point of failure that you run into with the Hadoop file system. Do you know how it goes about doing, like how it avoids that? Is it just like through that distribution across nodes?
Sorry, could you repeat that question again?
So how DSEFS avoids this single point of failure common in HDFS. Do you know how it avoids that?
Yeah.
That pitfall?
Yeah, because HDFS runs on Hadoop, and Hadoop has this concept of name nodes. Even if you have like 100 different computers in your HDFS cluster, the name nodes are required in order to understand where the files are. Whereas in DSEFS, that metadata is on a DataStax or Cassandra table, and Cassandra does not have a single point of failure, right? So that's how it does that.
Gotcha. So leveraging Cassandra is.
Yeah.
Gotcha. Okay, so I did add the link to this demo in the presentation. In this, I'm running it on Docker using DSE server as well as DataStax Studio, excuse me. So in this PySpark DSE cookbook, there are some built-in things to get you set up once you have it all connected. So let's go to my DataStax Studio. I imported the PySpark DSE cookbook file into DataStax Studio, and it allows you to run some commands right away and fill your create your key space table, all that sort of thing, which you can see here. I actually ended up running it twice, is what this little red thing is saying, that it already exists. So I had this up and running prior to the meeting. So you can see it creates a key space. And the simple strategy is kind of just the demo, you're trying something out, not recommended for production at all, along with the replication factor of 1. We create a table in here, user transactions as well as user sessions, and insert some data. Looks like these is simulating some sort of purchases. Yeah. We select all this just to show that our data is in our tables. Again, user sessions, just demonstrating the table as well, that it was created. Adding a new column by user ID. selecting that. So you can see this is essentially just creating the table, the key space, all of this sort of thing. And the part that I was unable to run, but the part that shows using Parquet Tables specifically, you can see we would SSH into the Spark instance. And using the Parquet file format, it seems to lean heavily on Spark in order to do this. You can see here, load, again, I wish I could demonstrate this for you guys, but I was having issues with this portion of the demo. Loading some user session data via a CSV into the Spark instance. And that's just displaying whether or not it's there. And then loading it into the data frame and saving that data as a Parquet. So you can see if you save as this Parquet file format, or this is actually a file in there. Essentially, okay, I need to go into these files. Sorry, you guys, to show it better. So you can see using SC and then this .parquet here is what allows you to access and load data as Parquet. So in this instance, it's reading. It can also be loaded, and it all comes down to specifying Parquet in your file format as you're loading the data in. Unfortunately, since I don't have this running right now, this is about all I could demonstrate. If there are any questions or if anyone has something to contribute, you can go ahead and do that now.
One of the things that I believe is true about Parquet tables, in Spark specifically at least, is that when you store a load from them, that they have the count row like stored with them. It's not calculating count, it's just going and grabbing it from the table. So it's a way to get very fast counts out of your data in Spark.
Mm-hmm. I know it stores metadata. The Parquet tables themselves store metadata, and then it being a columnar storage, yeah, I can see how that makes for the faster reading and writing. Any other questions or contributions anyone has? If not, that is pretty much all I have for right now. Okay, I take that as a no. You guys can stop the recording and